Molecular view of elements and compounds. So we've talked about this before. Pure substances can be divided into elements and compounds. Elements can be atomic or molecular, okay? Atomic elements, the individual pieces will be atoms. A molecular element is one where you have two atoms of the same element or more that are going to bond together. So if we look at oxygen, oxygen has molecules. O2 molecules. It's not in, the air we're breathing doesn't have oxygen atoms in it. I think of elements that do this as being a little bit like junior high girls. When I was in junior high, a speaker at our school pointed out that junior high girls almost never go to the bathroom by themselves. They always take a friend. I don't know why it is. And I was a junior high girl at the time, and I didn't realize I was doing that. But after that, I realized, yeah, I do that. I don't know what it is. They always go in pairs, right? So these are like insecure junior high girls, and they're always going to have a friend with them, okay? So some elements are like that, others are not. Compounds. Compounds can be molecular or ionic. We talked about what ions are. So an ionic compound has ions, and we talked about charges and how opposite electrical charges attract each other. The chloride ion has a negative charge, the sodium ion has a positive charge, and that causes them to stick together like magnets. Okay, it's not magnetic, it's electrical, but they behave in much the same way. Other compounds are molecular in nature, and here the hydrogen and the oxygen atoms are stuck together by a bond. For now, think of it as superglue. These guys are superglued together. So different divisions within elements and compounds. And now the slides are going to go over everything I just said. So atomic elements have atoms as their smallest particle. Molecular elements have molecules. Okay, these descriptions are not intended to deceive you. Another picture, here's mercury atoms. Mercury is just very neat stuff. Unfortunately, it's toxic, so we can't play with it. But if you look inside a drop of mercury, it's got individual atoms. Chlorine gas, on the other hand, chlorine is one of those insecure elements and goes around as diatomic molecules. Diatomic, two atoms, a two-atom molecule. These are the 7 elements that are the junior high girls of the element family. If these elements are present as elements, not as part of a compound, but as an element, they will always be diatomic. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So this is one way to remember them. Horses need oats for clear brown eyes. That's a stretch, but that's I, right? Sounds like I. So hydrogen, nitrogen, oxygen, fluorine, chlorine, look, it's even a Cl, bromine, Br, I. Those are the 7. That's one way to remember it, okay? Another way is on the periodic table. Let's get a color here. There's 7 of them, right? Starting at element 7, they make a 7 on the periodic table. Isn't that cool? And where's hydrogen? He is off being the baby brother of the elements, and he's not following with the others. So he's over there. So the 7 on the periodic table, starting with element number 7, plus hydrogen. You need to know these. Not for the exam on Thursday, but for the rest of the class. So compounds can be molecular or ionic. So this is important, and this is going to help us when we do nomenclature, because we need to be able to identify, is it a molecular compound or an ionic compound? Molecular compounds are formed from 2 or more nonmetals. 2 or more nonmetals. Ionic compounds are going to have ions, and they're usually going to contain a metal. There will usually be a metal and a nonmetal. Because what kind of ions do the metals form? Cations or anions? Positive or negative? Positive ions. Okay, and what kind of ions do nonmetals form? Negative ions. Positive and negatives are attracted. Those are going to stick together. If we tried to make an ionic compound with two nonmetals, they would both be negatively charged and they wouldn't stick together. So they can't make a compound in that way. They do it by sharing electrons. We'll learn about that later. Another example of ionic versus molecular. This is dry ice, which is solid carbon dioxide. And the molecules here, 1 carbon, 2 oxygens. If we look at table salt, you know, if you look at it, it's these little tiny cubes, right? It's like, do you think the manufacturer is making those little tiny cubes on purpose, as opposed to little spheres or something? No, that's just what salt wants to do, partly because it is ionic. If we look inside one of these little salt crystals, we will find that there is an alternating lattice of sodium and chloride ions. They just stick together by attraction between opposite electrical charges, and there are not specific molecules. In essence, you could say that that whole salt crystal is a molecule because it's the same throughout. Well, that gets awkward to deal with because some are bigger than others, right? So what we do for the ionic compounds is we talk about a formula unit. The formula unit is going to be the smallest whole number ratio of ions to each other. Yeah, so I kind of just said all of that. Basic unit of ionic compounds is the formula unit, not the molecule. And so they're alternating ions in a 3-dimensional array that don't have individual molecules. So classify each substance as an atomic element, a molecular element, a molecular compound, or an ionic compound. So let's just review here. An element will only have one type of atom. So when you look at the formula for it, it's only going to have one capital letter. Each element symbol has one capital letter. Some of them have a lowercase letter as well. But you can look at the formula and count the number of capitals and identify that way whether it's an element or a compound. A molecular element is going to be one of those 7 insecure ones. Horses need oats for clear brown eyes. The rest of them, for the purposes of this class, are atomic elements. Deciding between a molecular compound and an ionic compound. Look and see, does it have a metal, a metallic element in it? If it has a metal in it, it's going to be ionic. If it's nonmetals only, it's molecular. So let's look at this first one. That's not a formula, but it's just a name, chlorine. Is that an element or a compound? That's an element. Then we have to ask ourselves, well, what kind of an element? Is it one of the 7? It's one of the 7, so that's a molecular element. I'm going to call that me. And here's no. I like that compound. It looks like no shouting, right? N-O. Element or compound? Compound, because it's got 2 capital letters, the N and the O. So that makes it a compound. Is it ionic or molecular? It's molecular. If we look on the periodic table and find nitrogen and oxygen, they're both to the right of this stair-step line. 2 nonmetals, they can't form an ionic compound. So that's going to be a molecular compound. How about AU? That is an atomic element. We can see it's an element because it only has 1 capital letter. It's just 1 element symbol. And we can tell from its formula that it's atomic because there's no subscripts. If it was molecular, it would have a subscript, but we also know it's not one of those 7. Did any of you ever watch The Facts of Life? Very old TV sitcom. Okay, so there was Tootie. Remember Tootie? little black girl who's a real cracker. So she was studying chemistry, and the way she remembered the symbol for gold is, what do you say when someone steals your gold necklace? Hey, you, come back with that. No? Okay. Na2O, element or compound? Compound. There's two element symbols there. Ionic or molecular? Ionic. Because the first one, sodium, is a metal. That tells us it's ionic. CrCl3, element or compound? Compound. Ionic or molecular? Ionic. We find chromium. Chromium's kind of in the middle of the periodic table there. It's a metal. Any questions? Being able to identify things like this is the first step in being able to name them.